Okay, we'll finish out section 6.5, properties of logarithms, with two more properties and a formula that we need to know. In the following properties, m, n, and a are positive real numbers and a is not equal to 1. So if we're given that m and n are equal, then we know that we could take the log base a of m, and that has to be equal to the log base a of n. In other words, if these two are equal, then take the logs of the same base of both sides, and that should also be equal. On the other side of that, if the log base a of m is equal to log base a of n, then it must be true that m and n are equal. And for our formula, we have something called the change of base formula. As long as a is not 1 and b is not 1 and they're positive real numbers, then the change of base formula says the log base a of m is equal to the log base b of m over the log base b of a. Now, why would you change it to some base b? Well, typically what we would change it to is something we could calculate on our calculator. So those are the common log or the natural log. Most likely the b that we would choose to change it to would be base 10 or base e. Why? Because these are the ones on our calculator. So why would we use it? We would use it when the log is not 10, when the log base is not 10 or e. So then we would change it to this so we could use our calculator. That's when we would use it, all right? That would allow us then to continue calculating. If this is log base 27 or log base square root of 2, a could be the square root of 2, we can then continue on, change the base to either base 10 or natural. It doesn't matter which one. It shouldn't matter at all. Okay, let's see, or it will not matter at all. All right, so let's evaluate the log whose base is neither 10 nor e. So the log base 3 of 12 would either be the common log of 12 over the common log of 3, or if you choose, this is not an and, this is an or, so I'm just going to write or, you could use the natural log of 12 over the natural log of 3. Either way, you will get 2.2619 whatever, and to 4 decimal places. That's what it would be, to 4 decimal places. Okay? And this one, same thing. You could use the common log of 325 over log of 7, or you could use the natural log of 325 over the natural log of 7. Either way, you should get 2.9723, rounded to 4 decimal places. So we need to know this formula, which isn't all that difficult, right? The base goes on the bottom and the argument on the top, and just make the log either 10 or e, your choice. Let's summarize what we've learned about properties of logs. So when we had the log to any base of 1, it was always 0. When we had the base and the argument matched, it was always 1, but that's because the exponent on that a was 1. Notice when the exponent on the a is r, it's r, right? So this is really just a form of this one. Of course, a to the log base a of m was just m. When we had log base a of m times n, we could write that as log base a of m plus log base a of n, and the quotient is a difference with the numerator first. The log base a of m to the r, that r can become a factor. That's r times the log base a of m. And if m is equal to n, then the log base a of m is equal to the log base a of n. And if the logs are equal, then the two values are equal. And the change of base formula would change to, and I'm just going to go ahead and say either you would use log base 10 or you would use natural log.